Goddamn. Hello, good evening, people. It's so late. It's so late. It's so late. Can I fucking get rid of this, please? I might just be retarded. It does happen at time. Let me silence this computer. Computer, silence. You are too noisy. Okay, so it's late, I'm tired. I have not played video games or anything today. I went to the gym, which kind of counts as a hobby, I guess, because it's not work, it's not nothing. So today we at least need to review the things we've studied this weekend. At the very least, the bare minimum. I think it will take like 20 minutes if we're fast and focused. But to be fast and focused, you need to be well rested, and to be well rested, you need to sleep. But before sleeping, we need to review this. Anyway, so what is a parent? Very simple. It's an individual chosen for reproduction. Oh, I forgot about this. Choice of parents via crossover, it's the selection phase. Mutation, you just take the children and apply a random modification of the children. Crossover, you take the two parents, you combine them to get, that's the sleep time. If I sleep now, I have like 9 hours of sleep, so it's not that bad if I sleep like in 20 minutes or something. At least 8, at best 9, because I have like so much tiredness from the exam period, which was like 2 months ago. I know. But I never kind of really recovered. And because in March I had not that chill of a month, because we had a paper in the pipeline. Anyway, so a crossover, you take the two parents, you combine them, you get a child. You initialize, you evaluate. So initialize, evaluate, while you still have some NFE, you select, you cross, you mutate, you evaluate. Oh, come on. And then you replace, and then you return best. Init eval while select cross mutate eval replace. Yes. Evaluation, you just compute the fitness of all individuals. A candidate solution to a problem, it's like an individual. Creation of a initialization. Selection, you select the parents via tournament for production. Oh, sorry. Well, I would have gotten it. Initialization, I misclicked, but I know that I would have 100% guessed it. Initialization, evaluation, population is a set of individuals at a given iteration, of course. Offsprings, these are just individuals from parents that are combined from the parents. New individual, yes, kind of. Oh yes, look. The details is from combination and mutation, the other mutation. So I'll put it in difficult. Formation of a new population, it's like the replacement. That's the main step of genetic algorithm. Well, we have it right here. I would have gotten it. Initialization. Normally, if you have like a card like this that appears after a hints heavy card like this one, because you've seen this one first, this one you can guess it easily. So if you're really rigorous when you check it, of course you know it, but sometimes I put it here because I know that if I had not seen this one before, that was easier to retrieve, I would have had a harder time to guess this one. But in this current situation, it's so easy, so I can have it incorrect. Initialization, you just create an initial population of random individuals. Fitness, number of function evaluation, which is really a weird word. It sounds French as fuck. Is it true? Yes, it is. My bad. A whole paper on that? What the hell is this website even for? I've seen like some movies even on that, like the Hail Mary project. I typed Hail Mary project, I see ResearchGate as like the 8th result. Like, how? I wasn't aware Hail Mary project was a paper. Okay, so yeah, that's not bullshit, it's true. It's fact checked. Combination, so that's the crossover. Rate on the best individual. Pseudocode of genetic algorithm. Select. Combine. Parents. By default, elitism keeps one or few best parents and fill the population slots with best children's. You initialize the first population, while NF is this now. Select, combine, mutate, NFE, initialization, evaluation, selection, not mutation, combination, of course. Well, we have it right here again, but this time I'll put it in 2 because I don't want to explain. Initialization, evaluation, selection. A tournament, choose 1 parent. How to get the second one? You make another tournament, of course. Individual, a specific solution to a problem. Candidate solution. While you still have some NFE, mutation, that's the phenotype. New individual produced, that's an offspring, children. You start by selecting parents. By default, mutation apply only to children, yes. Fitness, compute at evaluation. Mutation, replacement, well, you use elitism to renew the population with children. By default, 2 tournaments, yes, they can, absolutely can. When does this, when no more NFE? Okay, so you have init select, before that you have like eval select combine mutate replace and stop. Representation of individual manipulated by that's the genotype. A tournament chooses one parent at a time. Oh, that's like the same one, but okay. Well, let's just select. That's easy. Select, combine, mutate, just making sure. Yes, very easy. I should have not put the other one in 2 because it's like trivial. Genotype is the representation of the individual manipulated by the algorithm from which you can derive the phenotype. Yes. Fitness is the quality per se of an individual. Man, I just had it. After mutation, you evaluate init phenotype. Phenotype is the solution as interpreted by the algorithm, solution in the solution space, solution's value in the solution space. From the genotype, of course. Crossover, mutation, evaluation, replacements. population. I'm sorry, it's like the same cards for like 3 days, same easy cards for the past 3 days. I'm just so tired and I have no energy, and it's always the wrong time to learn something new. But it will come, believe me. All of these are cards I've learned during my university, but after each year I was like, okay, I have no time to review these 100 cards, let me do that and I will review them tomorrow. But tomorrow it was like 300 and 450 and so on, and I just let this pile up, and it's a shame, it's a great shame, because you feel you are quite much more intelligent when you know all of this. Wait, because I've sent a very, very funny video, but people did not react. I am unhappy. Anyway, density. Oh, a density. A density is a function that characterizes density is a function that says how are the probability arranged in the solution space. Let me check if this is a viable answer. Then that's the performance. I like to change the. Oh, did something just happened in the website? Let me see. Do we have some news about it? Because they changed their interface for the first time in like a year. But does it come with new model? That's really suspicious. I can see some buffoonery. I can recognize some buffoonery when I see some. Yeah, I'd rather ask GLM because they have this brand new strong model. I can't. Can I use it in 5.1? Yes sir. Yes sir. Anyway, can density be defined as the function a function that describes that. I said some bullshit, but I meant that this yeah, describes how probabilities are. I like this word. How do you say réparti in English? Oh, distributed, yeah, I'm retarded. Distributed. The solution space. Okay, bro. No. Oh, I thought my question was gone. So much. That's not rocket science. This is insightful. Short answer, yes. Oh well, exactly. Because I know I had the gist of it, because that's how the prof described it. But I don't know if it was really rigorous or rather an approximation. But now we know. For deep full active learning, for each picture you apply deep full, you retrieve the minimal perturbation. Given the picture X and probability network F. Simple. This one is tougher, especially the last test part. I think. What are the hypothesis principle? Independence, normality, homoscedasticity. When more than two algorithms, what to do? Okay, post hoc tests. More than two group, parameterized, non-matched. ANOVA. One way ANOVA. Yes, sir. Matched data, simply data where one data from a group directly correspond to one data from the other group from some common characteristic. Oh shit, it was like non-matched. Okay, that's when I'm tired, I kind of mixed up. So it's the exact opposite of what I said. Okay, Friedman, when you have more than two groups. Friedman, I think it was when you have nothing. That's absolutely wrong. You are non-parameterized and you are matched. That's when you are parameterized and matched. That's when you have more than two groups, data such that that's non-matched data. How many groups? More than two. Matched and parameterized, repeated measures and above. Critical release. Well, I know this one is when you have nothing then. But see, because I derived it from a previous card. Critical release. And again, this one deserves to almost be here because I know it from the previous card. But let's not over-engineer it. Two groups, parameterized, matched but non-parameterized. It's the... I forgot the name. Critical release is nothing. I don't know. Okay, I know I would have probably never guessed it. Friedman. Okay. So I know it's when you are matched but non-parameterized. Two groups matched and parameterized. It's the come on. It's the one that repeats itself. I forgot. Lord forgive me. For I forgot. It's not crystal light because I've just seen it. It's not. It's the t-tests. It's the. There is two t-tests, and this one is the equivalent of the repeated measure ANOVA, but for t-test it's like pair of t-tests. Damn, that was difficult, but we have it. Non-parameterized but paired. Friedman. Two groups. Parameterized, non-matched. More than two. More than two. Test to perform after the main test. Blah blah blah. Yes, I know what a post-hoc test is. What tools to do that? The CRN, common random numbers. Match data is the definition I've given earlier. P-value is the value from tests that tells us how much the data correlates with the assumption. Oh, non-matched and non-parameterized. That was for the match. The match. I was not sure because parameterized. I know it's student, and if it's parameterized, test that allow to identify. That's the post-hoc tests. Pipeline to know what tests to use. What signifies a p-value? A low p-value. It means that data are not compatible with H0. Therefore, we must reject it. H1 is the is the hypothesis we support that generally states that there exists a significant statistical difference between the two data groups. Matched data and parameterized. Homoscedasticity simply means the variance between both groups or all groups. They are comparable, more or less, of the same shape. Data suggests that each observation from a group corresponds to that's the match data. Two. I'm so tired. Anyway, parameterized and non-matched. T-test. Actually, let me do something. Then. Ah, there's me. Just a bit. Just a bit. I would have been surprised I have any other cards in my 10,000 card deck with t-tests. Because when you search here, which is really dumb, it's like all the cards of your decks, even though you are like in some specific deck. Anyway, so two groups, non-parameterized but match. It's the Wilcoxon sign rank Wilcoxon. It's quite a bit of luck. When to reject HO compared to alpha and p-value. Well, when p-value is below alpha, of course. Alpha is the threshold by which you consider the data non-compatible with the hypothesis. Wilcoxon two groups. Determine the number of groups, verify and check the parameterized assumption. Command random number. Pipeline of statistical. Well, you check your number of groups, you check if your data are matched, and you check the parameterized hypothesis, and then you just take a test. Quantity that measures to which point data. That's the p-value. When you have two groups, pipeline, I just get in, analyze. That's the specific term is not that important, but let's try to remember it. Single problem analysis. Parameterized. Whitney U. Man Whitney U. Independence. Simply when a run doesn't affect the following run. The data points. CRN, they are used to add pairing between the data to reduce the variance. So I was saying it earlier, it's like matched. Are your data matched? I am tired. Choose tests. Normality. Do the data follow roughly normal distribution? Alpha. That's the default hypothesis that generally states that there exists no difference in independence, homoscedasticity. Check for group numbers. Two groups, non-parameterized tests. You use them when you cannot check independence, homoscedasticity, normality. No. Non-parameterized but matched. Normality, CRN, H1, hypothesis, alternative hypothesis. And that's a type of analyze when algorithms are tested on one problem only. Because if it's like multi-problem, you have a different outcome. Default hypothesis, H0, okay, that's great. How long was it? I said 20 minutes. Look at that, 20 minutes. Looks like I know my craft. Anyway, I'll tell you goodbye. That's a very short video. I'm tired. I'll go to sleep. No need to stay up if I'm already tired. Because good sleep allows for a good productive day, which allow for a good free evening where you can do whatever you want because you've worked enough in the office. Anyway, kiss kiss.